Hello and welcome to podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who supports the show on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app. And now you can deliver your work to your users even faster with the newly upgraded 200 gigabit network in all of their data centers. If you're tired of cobbling together your deployment pipeline, then it's time to try out GoCD, the open source continuous delivery platform built by the people at ThoughtWorks who wrote the book about it. With GoCD, you get complete visibility into the life cycle of your software from one location. To download it now, go to podcastinit.com/GoCD. Professional support and enterprise plugins are available for added peace of mind. You can visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. And if you have any questions, comments, or suggestions, I would love to hear them. You can reach me on Twitter at podcastinit or email me at hosts@podcastinit.com. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host as usual is Tobias Macy, and today I'm interviewing Bogdan Popa about Dramatiq, a distributed task processing library for Python with a focus on simplicity, reliability, and performance. So Bogdan, if you could start by introducing yourself.
Hi Tobias, I'm Bogdan. I'm a independent contractor currently working for Lead Pages, a marketing software company for medium to large companies. Been doing web development for close to 8 years, and I've been using Python for about 10 years at this point.
And do you remember how you first got introduced to Python?
Yeah, I was a very early user of Reddit way back when it used to be implemented in Lisp, and then they eventually switched to Python, and that's when I first heard of it. And yeah, I was doing PHP at the time, and I don't know, it looked interesting, so I dove into it. I liked sort of how readable it was. I liked the ecosystem, and just, I've been using it ever since.
And you started building the Dramatiq project, so I'm wondering if you can just give a bit of an overview about what that project is and what was your motivation for creating it.
Yeah, so Dramatiq is a distributed task processing library. So if you've used things like Celery or RQ, you're probably familiar with the concept. Basically, you write your functionality such that, say you've got a web request that you're processing something in, you can split out some of the functionality of that web request and put it on a worker somewhere. So essentially, you write a function, you send a worker a message over the network to process that function, and Dramatiq sort of helps you orchestrate that whole process.
And as you mentioned, it sits in the same realm as projects such as Celery or RQ, which most people have probably heard of one or both of those. So I'm wondering if you can just do a bit of compare and contrast between them and Dramatiq.
Sure. So Dramatiq actually I built Dramatiq because of my frustration having used Celery for quite a long time professionally. Essentially, I tried to fix some of the things I found to be problematic with Celery. Things such as, really, to start with, just having a much simpler, easier to understand code base. If you've ever had to dive into Celery source code, you'll know that it's spread across 3 projects, Billiard, Kombu, and Celery, and it's, as you would have expected of any open source project that's just grown organically over time. Entropy took its toll, and so some things aren't as well designed as I would like them to be, and I personally think it's a little bit spaghetti, which has prevented me from diving in and contributing in the past, and I'm sure it has others. So that was one reason. Dramatiq's code base is much more straightforward, much simpler. Another big one is I've used Google App Engine a lot, and Google App Engine provides a task queuing system that is extremely easy to use and just very straightforward. It relies on convention more so than configuration, and I that just meshed very well with me. You define a queue, and then you're able to process messages on it, and then you're obviously able to configure some things, but it's It's very straightforward. Any uncaught errors are just retried with backoff and all that stuff. Now, by default, Celery doesn't do any of this. And you're able to build this stuff around it, but really, I think it makes more sense to have this be the default. So when I write my tests, I need them to be idempotent. I want my system to like automatically handle any errors that I haven't thought about. I want it to retry them later, all that sort of stuff. And I don't want to think about, implementing retries and things like that. And you mentioned RQ. I don't think RQ actually handles any of that, but I have to admit I haven't used it very much. Yeah, and then there's other things like locks and rate limiting. In the projects I've had to work on, these have been very important. Celery has per worker rate limiting, so if you have a task and you want to limit how often it runs, that limit only applies to the one worker process. So if you, in an auto-scaled environment, for example, that isn't very useful. So Dramatiq provides global locks and global rate limiting and other things like task prioritization. So for example, Celery 4 now provides RabbitMQ users a way to prioritize messages within a queue, and that's good. The problem is it doesn't give you any way to prioritize messages across queues, which again for me is kind of a big use case. So Dramatiq solves this problem as well. And I guess another big one, or another two large ones, one is automatic code reload. When your code changes, it's kind of nice in development for the workers to actually just reload automatically. Celery used to have this feature in Celery 3. In my experience, it never really worked, and they actually removed it in Celery 4. So that was a big one. And then the other one is just the fact that Celery's implementation of delayed tasks, that is, tasks that you schedule to run in the future, isn't that great. The way it works is essentially those messages are put on the same queue that normal messages, that is non-delayed messages, are put on. And so what the workers have to do is they have to pull all of those delayed messages into memory. But of course, because memory is limited, it actually has a limit on the number of messages that it can pull. So if you have many messages that are far off in the future, so for example, if you have a system that fails very often and is very high throughput, you can end up in a situation where you have a ton of messages that are all delayed and have been pulled into worker memory, and many new messages coming in, but those new messages aren't getting delivered to workers because those workers actually have to wait for those delayed messages to execute. So another thing I set out to solve. And the way Dramatiq solves that is it just has separate queues for normal and delayed messages. And so it does the same thing where it pulls delayed messages into memory, but those don't actually interfere with normal messages. And when a delayed message is ready to be delivered, it's actually enqueued on the normal message queue, if that makes sense.
Aside from delayed messages, one of the things that I've used in Celery is the idea of scheduled messages, somewhat similar to like a cron interface where you can say this task should be executed either every 4 hours or at 3 o'clock in the morning on Tuesdays. Is that something that Dramatiq supports as well?
Dramatiq doesn't currently support that, and I'm not sure it's ever going to. There is an open issue about it, a feature request about it right now. I think what I'm going to encourage people to do is just use AP Scheduler with Dramatiq, because that's a pretty solid piece of software, and there's not a lot of reason for me to duplicate that functionality because sort of the main message broker for Dramatiq is RabbitMQ, and there isn't a very efficient way to use RabbitMQ as that sort of a scheduler. At least I don't think you can do it without plugins. So I would end up just duplicating a lot of AP Scheduler's functionality, which I'd rather not do since it's a stable, good project.
Yeah, it's one that I've used in the past as well, and I've found it to be, as you said, quite reliable. It was actually written by a past guest, Alex Gronholm, who I spoke to about his Asphalt project as well. So definitely a prolific engineer who's done some good work there. And some of the other features that Celery has that are sometimes useful are things like task chaining. I'm not sure if that's something that is possible in Dramatiq or something that you haven't really found much use for.
So I've used task chaining extensively, and sort of ran into issues at scale with it, but partly because of the backend we were using. Essentially, in Redis, task chaining depends on, or if you want efficient task chaining, then you must have a result backend that has support for atomic increment and decrement. Otherwise, it falls back to polling, and it can sometimes drop those chains. And even when you do use a backend such as Redis or Memcached, this is getting into sort of ops problems, but those two can drop messages just by virtue of the LRU pushing keys out of the cache. More so Memcached than Redis, though. But getting back to Dramatiq, it doesn't have that built in right now, but it's fairly easy to add. The main extension point with Dramatiq is the notion of middleware. So essentially, you would write a little chain middleware that is able to hook into the message lifecycle and handle all of that. Of course, you would need some shared storage system, so you would still need something like Redis or Memcached. But it's not in there quite yet. I'm not sure if there is a lot of demand for something like that. I'll probably add it, but for now, I think it's probably best to stick with simple tasks and simple flows, because I found those are also just a lot more debuggable than like Celery's API for doing chords and groups and all that stuff is very, very nice, and it's elegant and everything, but it doesn't. At the end of the day, it's not nearly as simple as just having your task call another task at the very end of its run. Of course, there are more complex things that wouldn't solve. But
yeah, having tried to use some of the task chaining capabilities and getting bogged down and trying to figure out how it all flows together, it's definitely something that, while conceptually very nice, is sometimes difficult to actually have work properly and reliably.
Yeah.
And you mentioned that Dramatiq has the capability of being extended via middleware. So I'm wondering, what are some of the other use cases for that middleware or examples of middleware that you've written or used?
Well, so a lot of its functionality is actually built on middleware. So, for example, the automatic retry functionality is built on middleware. The task runtime limits, which is a middleware that lets you kill tasks that have been running for too long, is also built on middleware. There is a middleware that exposes worker metrics over Prometheus, and yeah, most of the functionality that's not just the core of running the worker, pulling messages, and executing those messages is actually built using middleware.
And digging deeper into the project, I'm wondering if you can discuss how Dramatiq is implemented and how the internal architecture has evolved over the time that you've been working on it.
Sure. When I started on it, I already knew, like, having used systems like this for quite a long time, I already knew what or how I would like it to work. So the architecture is pretty simple. You have your worker processes. Each worker process has a shared work queue, which is just a Python priority queue. The worker process spawns multiple worker threads, and you're able to configure this. By default, it's 8 worker threads per process. You can switch to 1 worker thread per process, depending on what your use case is, or more if you're using something like gEvent. Alongside those worker threads, it spins up consumer threads for each queue that you have defined. And essentially, the consumer threads are the only things in the system that interact with the broker. So the consumer threads just sit there and wait for messages from the broker. When they get a message, they put it on that shared priority queue, and then the worker threads simply consume messages off of that shared priority queue and then send an acknowledgement back to the consumer thread. So it's queues all the way down, because you've got your broker and then you've got in-memory queues and everything. But yeah, that's sort of the design at the high level. Initially, I had it where so I should take a step back. So Dramatiq has at least one message, at least once delivery semantics, and so it relies on RabbitMQ's message acknowledgement pattern. So essentially, the consumer takes a message from RabbitMQ that moves it from ready to unact. Then the worker processes the message, and then eventually that message is acknowledged back to the broker. And at that point, the broker removes the message from the queue. If the consumer or if the worker process dies at any point during this, then the message will simply get redelivered later. So initially, the way I had it set up was the consumer thread would pull a message, then send it to a worker thread, and then the worker thread would acknowledge the message. But I quickly ran into the problem that Pika, I actually don't know how to pronounce it, which is the client library for RabbitMQ that I'm using, isn't thread safe. So the worker threads would sometimes clash with each other and with the consumer thread. And so that's when I changed the design from both the worker and the consumer communicating with Rabbit or any other broker to just the consumer doing the communication. So essentially, there's a queue for incoming work, and then there's a queue from workers to consumers for message acknowledgements, if that makes sense. But yeah, for the most part, the design is the same as I had thought about it prior to actually starting to work on it, because I've honestly been dreaming of something like this for a long time, which is kind of sad if you think about it.
And what have been some of the most difficult or challenging aspects of building and maintaining the project?
Well, so one thing that was a bit of a challenge is, if you're familiar with RabbitMQ, you might know there's this quality of service setting that you have per queue. You're able to specify for each consumer, all right, here's the total number of messages I should process at any one time. And the point of this is for consumers not to steal work from each other when they don't have to. So let's say you have 8 worker threads, you probably don't want any more than, say, 8 or 16 messages to be consumed for that process at a time. And that's the general idea. The issue I ran into with this design is the consumer would block waiting for messages from Rabbit with an idle timeout. So it would get, say, a chunk of 16 messages. It would pass those to the workers. The workers would process them and then send those acknowledgements back to the consumer. The problem is the consumer would probably still be blocking on that network call, still waiting for new messages. And so acknowledgements would be delayed. And because acknowledgements were delayed, the broker wasn't going to send any new messages down because the consumer had already accepted 16 messages, or however many it had. So this turned out to be a small problem because out of the box, Pika doesn't let you interrupt that blocking call. So I had to work around that. Fortunately, it's kind of easy to work around just because of how Pika itself is architected. I did kind of have to depend on some of its internals, but I have opened an issue on their GitHub page asking whether or not they would like me to port or to add this functionality to Pika, because it's kind of nice. So essentially the idea is we still do the blocking call. We still efficiently wait for either new messages to come in over the network or for acknowledgements to come into the consumer. The difference is the workers are able to actually tell the consumer thread to wake up when a message is ready to be acknowledged. And yeah, this turns out to be quite the CPU usage of this is very good. It's as if you had actual blocking system calls everywhere, because they are actual blocking system calls everywhere. And the throughput is also very good. In fact, it's a bit faster than Celery is at processing many messages. That was kind of long-winded, but I hope it makes sense.
That was great. Thank you. And you've mentioned that RabbitMQ is the main implementation target for the message broker, but it also has support for Redis. I'm wondering how complicated it would be to add support for additional message brokers in the future.
It depends on how different they are from RabbitMQ. Like I said, RabbitMQ is my main target. I've used it for years, and it's very solid. Adding new brokers is actually fairly easy. The API is quite small. You really only need to define methods for declaring a queue and you need to define what is essentially just an iterator that grabs messages from that queue. So the API surface is very small. I've looked into adding things like support for things like SQS and Google Cloud PubSub. They're doable. I haven't added them to the core because I don't really want to support them. But as external packages, they should be really, really simple to set up. Yeah, it's like the main reason behind that is just because I'm not likely to use them. I'd rather not have to support them myself.
No, that's totally fair. That's the sort of perennial dilemma of any open source developer or contributor is, and as soon as you say yes to any feature, then you're stuck supporting it for life. And
right.
Sometimes you may end up regretting that in the future. So it pays to be judicious in the feature set that you implement, because then it just sort of compounds the amount of work and effort that's necessary to keep the project healthy. Whereas if you push some of the other functionality into third-party projects, then it distributes the workload more and allows you to call on other people to help in that maintenance.
Exactly. And it means people who are actually, experts in those domains get to build that stuff, because I'm not an expert in SQS by any means.
And are there any features of the project that we haven't called out yet that you are particularly proud of or think that deserve a special mention?
So one thing I'm quite happy with that's different from, at least from Celery. RQ, I think, has something similar when it comes to unit testing. So generally, when you want to unit test Celery code, you just turn these flags on that let your tasks run eagerly. It works out okay. Say you have integration tests where you're actually testing, what a call to an HTTP handler does. That ends up working okay. My problem with it is it's not close enough to the real thing. That is, if your task always runs eagerly, then it's as if that handler was fully synchronous, which in the real world isn't true. So instead, what Dramatiq does is it gives you a way to run your tasks asynchronously. It essentially gives you a way to run a worker thread and an in-memory broker to process your tasks in unit tests. The API isn't quite as nice as I would like it to be yet, but it works out well, and all its tasks or all its tests rely on that. In fact, that leads me into another thing that I think is worth calling out. Dramatiq has over 95% test coverage right now. It's actually pretty well tested. And another big thing for me is Celery has tons of documentation, but it's kind of, I don't even know how to describe it. It's so large and so, it's not very cohesive in my opinion, and it's kind of hard to get into. You'll find yourself constantly referencing it and constantly searching for things. That's another thing I tried to do better with Dramatiq. It has a simple, straightforward user guide and then very, very good reference documentation that's easy to find. So that's one thing I'm particularly proud of.
And for somebody who's interested in integrating Dramatiq into an existing application or into a new application, can you describe the steps that are involved in that process and the user-facing API for how they would add those tasks?
Essentially, it's plug and play. So you just pip install it, import it, and then you use this decorator called actor to do @Dramatiq.actor and then decorate some function with that. And that's really all you need to do. All actors are just normal Python functions. And so you can take any function in your system and turn it into an actor. Actors are what Dramatiq calls tasks. And then there's also an API for declaring sort of class-based actors, but I prefer the functional API. And that's really kind of the extent of it. It just, by default, it assumes you're using RabbitMQ and that it's running locally. If you want to configure that, then all you have to do is just instantiate a broker and then set it as the default. Should mention there are integrations for Django and API Star to make this a little easier.
And in the documentation, it mentions that in order to allow Dramatiq to process which functions are decorated properly, it needs to be instantiated fairly early in the startup process of the application as well.
Yep. Yeah, that's true. So when you declare your own broker, you should do it as early as possible in the startup process. It's also it's possible to not depend on that. The actor decorator actually takes a broker parameter. So you can specify, you can actually have multiple brokers in your system, and you can specify what broker to use on an actor level. But the default is to have a global broker, and which, if you want to use that, then you should instantiate it as early as possible.
And if someone is already using Celery or RQ in their system, is there any sort of easy migration path or compatibility layer for people to be able to switch those implementations over to using RQ? Or is that just too complicated and potentially fraught with errors to be a realistic migration?
I think it would be doable. I just haven't really spent any time on it. I think really the process of switching is simple either way. There's only a few things you have to grep for in your code base and then change them up. Essentially, you're just switching calls to celery.task to Dramatiq.actor, and then calls to task.delay to task.send, which is what Dramatiq uses to send actor messages. Obviously, that's oversimplifying things a bit. If you're using very advanced features, that might not work as well. But no, there isn't a shim right now.
And another issue that could potentially crop up is with the at least once delivery semantics, where you want your tasks to be idempotent. So if somebody isn't already designing their Celery tasks or RQ tasks to work in that way, they may end up having some issues with maybe repeat tasks because of a failed worker that didn't acknowledge the task before it completed.
Right. There are ways to work around that. Essentially, you can't, in Dramatiq, you can't actually get around the late acknowledgement thing. So regardless of your retry settings, if your worker process dies in the middle of processing a task, that task will definitely get re-enqueued later. If that's not what happens, if you have unhandled errors and you don't want the task to be retried, then you can just specify that as an option when you declare your actor. You can just say retries none. And additionally, you can leverage middleware here. You can have a sort of unique task middleware, for example, that just uses something like memcached to ensure that any task is only processed once over some period of time based on its parameters.
And are there any particular situations or use cases where you would advise against using Dramatiq?
The one big one is Dramatiq is Python 3 only. So if you're stuck on Python 2, then, well, for one, I'm sorry. For two, there's your options there are Celery, RQ, or one of the other text processing libraries that are out there. I didn't, since it's such a new library, I didn't feel the need to add support for Python 2, but I know people depend on that to some extent. And another one is, if you really do depend on extremely complex workflows, for example, if you're using Celery and you do depend on super complicated chord group combinations, then that might be a better option right now, at least until I add some sort of nice middleware to the core for doing that kind of stuff. But otherwise, I don't think so. Personally, I wouldn't use anything else, but I'm biased.
And going back to the idea of making the project sustainable, I noticed that you have a dual licensing structure for, if people want to use open source, it's GPL v3, I believe, and for commercial use where somebody doesn't want to release their modifications, you offer a paid commercial license. I'm wondering if you can just describe the licensing structure there and your reasoning for taking that approach.
Sure. Well, so I've been building open source software for a while now, and something I've noticed both in my own projects and in other people's projects is essentially you go out, you try and solve a problem that you have, and then other people start using it, which is good, but they start depending on it to some extent, and you're stuck supporting it. In the open, that ends up being you get issues, pull requests, all that stuff, which again is a good thing, but you also get companies who start to depend on your work and they start to make a profit on your work. And I think it's only fair to ask those companies to contribute back in some way. So for me, that's either they have to contribute source code, either their own or whatever it is they're doing, or they have to pay me to actually support the project. And that materializes itself in a $2,000 a year commercial license. And that said, I do also offer just free versions of that license for companies that are just starting out, because I understand that not everyone is currently making a profit. Oh, and I should mention, you said GPL v3, it's actually AGPL. So it's the Affero license.
Thank you for that clarification. And from a practical standpoint, given that particular license, what are the situations in which somebody would need to release the source code of the project that they're working on? Or what are the boundaries of code changes that would need to be released? Is it purely changes to Dramatiq itself, or does it somehow interface with the application that they're building as well?
It's any source code that interfaces with the Dramatiq API. So if you import Dramatiq and you use it, then you need to open source your code. That's the extent of Affero. So it's sort of like the LGPL for network code. That's how I think about it.
And how did you choose the price point for the commercial license? And have you had any success in selling any of those licenses?
I chose what I thought was sort of a fair amount of money. It's to be completely honest, it's somewhat arbitrary. It's just that seemed fair to me, and that's what I chose. I have not had any companies purchase it yet. I have had companies express interest, no purchases yet.
And about how long has the project been around? When I was looking at it, it seems that it's a fairly recent project.
Yep. I started working on it in, I believe, March of this year, just slowly working on stuff in my free time, just building out the things I thought it needed. And then started showing it to people in November of this year, so about a month ago. And it's had some uptake, but yes, it's a fairly new project.
And what are some of the features that you have planned for future releases?
Right now, I'm mostly focused on just using it, making sure that the things that are there are as solid as they can be. The one feature I am thinking of working on is adding support for pluggable encoders. that right now when you send a message over using Dramatiq, that message is encoded as JSON, and you have no hooks into that process so that you can, for example, if you're sending a UUID object, there's no way for you to automatically convert that UUID to a string, so it can be sent as JSON. So I'm planning on adding something like that right now, but that's the biggest feature I'm currently thinking about. It has most of the things that I've wanted professionally. So yeah, that's kind of it.
All right. So for anybody who wants to follow the work that you're up to or get in touch with you in the future, I'll have you add your preferred contact information to the show note. And with that, I'll move us into the picks. And for this week, I'm going to choose the book The Anybody's by N.E. Bodie, which is a book that's targeted at sort of probably about 8 to 10-year-olds. Been reading it with my son, and it's a lot of fun. It's very tongue-in-cheek, has a lot of references to other literary works, and the author sort of breaks the fourth wall a lot of times and talks directly to the reader in very humorous fashion. So it's been a lot of fun. It's the first of a series of books, and I've been enjoying that. So I definitely recommend that for other people. And with that, I'll pass it to you, Bogdan. Do you have any picks for us?
My pick would be pipenv. I've been using it for I'd say maybe 2 or 3 months now, and it's honestly it's great. it's what I've wanted out of Python packaging or Python package management for a very, very long time, and I'm happy that someone finally took that up. So pipenv is a sort of the analog of something like bundler or cargo from Ruby or Rust for Python. It wraps pip, and yeah, I would just recommend people look it up and use it because it's great.
Yeah, I've been using it for a while as well. And one of the other nice things is that it has the option of consuming a requirements.txt file to convert it into the pip file format, as well as producing a requirements.txt file for deployment systems that aren't yet able to use that pip file format.
Yep, that's a great feature. And the actual, verification of package hashes and just the lock file. Yeah, I've liked everything about it so far. I'm really happy it exists.
All right. Well, I want to thank you for taking the time out of your day to join me and talk about the work you've done on Dramatiq. Definitely seems like an interesting project that fills a valuable use case. So I appreciate your time, and I hope you enjoy the rest of your day.
Yeah, thank you for having me. Have a good one.